Welcome everyone to week number 2 in Science 214. I'm glad to have you back. Thank you so much for your discussion board postings in week 1, introducing yourselves and sharing with us issues that have to do with your particular community that you have seen that are STEM related. I can definitely identify with some of those that you have written about because I have some of the same issues in my community. I'm looking forward to the projects that you're going to be choosing this term so that we can learn more from each other about things that affect us personally in our lives. So, I want to go through a little bit of the science before we get into the assignments that you have this week. So let's talk about this. This is all about how science works and things that we should notice when we're looking at research, when we're looking at information out there in the world. First of all, you need to choose relevant sources. And so this means that the source has something to do with the topic that you have chosen, right? So if you have chosen, say I'm interested in the effects on the marine life off the coast of South Carolina from ocean acidification, and I choose a source that has to do with nuclear energy, that doesn't have anything to do with ocean acidification, right? Or maybe in a totally roundabout way, but no, that's not an appropriate source for my particular topic. So relevant, does it apply to what you're interested in? All right, then you're going to determine the credibility of the authorship. Find out who the author or authors are. Find out their education. Look to see where they're from. Look to see if they have expertise. I will guarantee you, when you look at the end of an article, that author will have put themselves and their references, their former references, their past references in that list of references that they have for this article, because of course they want to cite their own work. So look for credibility. Validity of data. Did you test for what you said you needed to test for? Or was it totally off the wall and it means nothing and it has nothing to do with this issue whatsoever? So you're looking for the validity of the data also. And then there are biases. So we are human beings as scientists, and we bring bias into our thinking. And that is true for all human beings, because bias is just basically taken from experiences that you already have and looking through that lens into other new experiences. But as scientists, we want to take out bias. There's all kinds of bias out there. The researcher themselves brings bias into the situation because I've done a lot of background research. I know a lot about this topic and I have expectations. I think when I set up my experiments that I'm going to get a particular result. And that means when I look at confirmation basis, that is the result that I'm actually looking for. So if something surprising happens, I think, well, that's just a fluke, something's wrong, blah, blah, blah. But it actually may be a very, valid result that I'm getting. The design of your experiments can reflect bias. The subjects that you choose can reflect bias. One example of this, for at least about 50 years, all coronary heart disease issues were studied through studying white males 40 years old and older, high socioeconomic levels, right? Does that reflect the whole population? Absolutely not. And so we knew nothing about these other populations of people and how coronary heart disease affects them. So you got to be careful with your subjects and implementation of your experiments too. Just the way you carry them out can reflect bias. And then finally, something really, really important for you to look at is who funded the research. So if you're doing a study on GMOs, genetically modified organisms like GMO corn, for example, and you want to know the human health effects of consuming them, and Monsanto has funded your project, you better believe Monsanto wants you to say that there are no detrimental health effects caused by GMOs. Now, what if that's not what you find? If you're a true scientist, you will report what you have found. Now, what does that mean for your funding? You will not get funding from Monsanto in the future. I'm just saying. And they also will not allow you to publish that work because they're paying for you to do this research. And they will also decide whether it gets published out there in the world. So look at the funding. If the funding comes from NIH, the National Institutes of Health, Washington, D.C., then there is no bias there because NIH doesn't expect you to come up with any particular kind of conclusion. So you know that you can just observe what you observe and explain what you have seen. That's it. And I put etc. because there's lots of other types of bias. Okay. Now on to your assignments. Your discussion board postings this week. Remember, initial post is due by Thursday. The 2 response posts are due by Sunday evening before midnight. Okay. Consider a hot topic in science today, where there's some controversy, where there's arguing back and forth, whatever, you know. And I put some here. COVID, climate change, considering the environment versus development in your community, different kinds of energy sources, GMOs. There's all kinds of hot topics out there, all right? How can bias impact the way that whatever your topic is that you've chosen is represented in the media, right? So if you're an environmental group in California, you better believe that they're going to come with a point of view that the environment is the most important thing having to do with urban development, right? If, on the other hand, you got a bunch of real estate people over here and this is their viewpoint, then they're going to say urban development is more important than the environment. We have to create spaces for people to live in. So you have to look at bias and who brings what kind of bias to a particular topic. How might public opinion be swayed by bias? Wow. That's a good question. That's the question of the day with social media these days, right? I can't wait till you see what you write about that because literally there is so much of that now. All right. And then your 2 response posts. How can public opinion, go back up there to your initial post and look at that. How can public opinion impact decisions or policies on topic X of your classmates? So you're responding to your classmates' initial post and all about what they say about public opinion and how it can be swayed. So then, how can that opinion impact decisions and policies about climate change, about selling GMOs, etc.? How can public opinion impact people's behavior? Oh, wow, that's a good one too, especially in the light of social media these days. I can't wait to see what you're writing about this. And how can citizen science combat bias? Right? If you bring facts, if you bring data to the table, people can't argue with that. They just can't. If you show them right in their face, here's the data that supports what I'm saying, there's really not anything they can say about that. Okay, so those are your discussion board postings this week. All right, this next 3 slides will be on your project proposal for week 2. Use the project guidelines and rubric, and that is going to be my mantra through the rest of this term. Use the guidelines and the rubric. So what the heck? Some people don't even know what those words mean, right? Because that's educationese, right? Guidelines, the instructions. That's all that means. The instructions. What to include, how to include it, how to write it, what form to put it in. That's the guidelines. The rubric is the grade sheet. So that's how I'm going to grade whatever it is that you turn in. You're going to see what the categories are, what I'm looking for in each category. That's the rubric. Mainly focus on the guidelines. If you do that, you will, excuse me, I'm getting hiccups. You will do fine with the rubric. All right, so this is for assignment 2, the project proposal, right? And this is so long, and I hate to put this much here, but I'm going to do it this time so that I don't miss anything, so that you know what the guidelines look like. So you have chosen a large topic, like the environment. All right. That's a gigantic umbrella of topics, right? So, like I said, if I wanted to choose the effect of ocean acidification on marine life, especially like shellfish, off the coast of South Carolina right now, that is a local issue for me under the more broad umbrella of the environment or also climate change. So my more focused issue, my more specific issue is the effect of ocean acidification on marine life off the coast of South Carolina right now. Find 3 sources about your issue. There are lots of ways to do that. You can look at the sources that are contained in our website. They're not going to be specific enough for you. I'll tell you that right now. They just aren't. So instead, go to the Shapiro Library. The Shapiro Library is a wonderful resource for us. And put in enough search terms, enough specific search terms that you can find good information. Now, what I'm also going to suggest is when you filter the sources that you pull up, choose the academic sources, right? Because you have different categories: academic, news, I don't know, books, I don't know, something else. Choose the academic sources, and especially eliminate the news sources. You don't want those because those are absolutely all secondary sources. All right. Then you've got your 3 sources. You've read through them. Another hint for you. Even if it looks like it's a bunch of gobbledygook when you pull up this source and it's written in a scientific way, you can find almost all of the information that you would ever possibly need in the abstract. It's going to be the first paragraph in the work. Use the abstract. It tells you everything that's contained in that article. It tells you what the question is. It tells you how they went about answering it. It tells you what the data indicated. It tells you what their conclusions are and what their further questions are for the future. It tells you all of that in the abstract. So look at the abstract, okay? So now you've reviewed your 3 sources. You've gotten the reference information from them, right? Because you don't want to lose them. Select one of your sources. All right, now take a look at it. What's your initial response? Good, bad? Does it hurt your feelings? I doubt that, but anyway, you see what I'm saying. What's your initial response? Do you recognize this source? Do you recognize where this came from? Could there be any bias coming from this particular source? Is this a good source for your research? Now, you should have chosen 3 good sources, so hopefully the answer to that is yes. Now, let me explain that when you are writing up this project proposal, you're not just answering these questions. I recognize the source. There is no bias. It is a great source. No. You're not just answering the questions, right? You're writing this up and explaining this. Okay. All right, number 2 for part 2. Is this accurate, reliable information? That's why you don't choose news sources. Accurate. Point on, right? That's exactly what you need answers to right here. Reliable. Can you count on this source? Are they experts in this topic? Did they do the research properly? Okay, accurate, reliable information. Where did the source come from? Is it a reliable source? Where was the research conducted? What was the date? Now, I know that in this course, somewhere in this course that I've read already, but I can't find it, is that current is always best. All right. I have to qualify that. You do want current information. You want the latest information that's out there, right? But in science, we have to look back also what other researchers have found. And don't forget about important work that has happened before us, because this is all built a body of scientific information, data, facts out there, right? So if the date is 2021 and you think that's too late, no, it's not. If it's 1800, then maybe, yeah. They didn't even have microscopes then. Okay, anyway, the date. Okay, the date's important, but it does not have to be yesterday. Accurate. Is the information accurate? One way to find this out is to look to see if it's been peer-reviewed. If it has been published in a scientific journal. A journal is basically a magazine where scientists publish their work, right? And now everything's online. So, if it's published in a scientific journal, it has been peer-reviewed. The peer review process is very important. Let me explain a couple of things about that. So what happens with peer review is before you even turn anything over to a journal, you have run this information past everybody that you know in your lab, people outside of your lab who work in different groups. You're asking everybody to read through your work and make sure everything is good, it's understandable, I've done the right things, I haven't forgotten something, right? So it's peer reviewed there. Then you send your work to a journal, and the journal will send out your article that you have written up your research in out to different peers of yours, and they are experts in the same field, and they will read through it, and they will make comments, and they will send that back to the editor, and then the editor decides whether your work is going to be published or not, whether it can be published with changes, or whether it will never be published a day in the near future on this planet Earth. That can happen too. The peer review process is really important before your work even gets published. But then it gets published, and everybody out there in science can make comments about it. They can write to the journal and ask the journal to retract your information, which has happened with really high-level, important, influential scientists. That has happened before, and their work was retracted. So the peer review process is extremely important in science. It keeps everybody honest, and it just finds mistakes too. I mean, not everybody's dishonest. Sometimes just mistakes happen, or you didn't consider something, or whatever it is, right? And does this work have references? So is the author or the authors referring back to other work that has previously been done in other subdisciplines, that sort of thing? Who is the author? Do they have authority on this topic? I already said that. All right, credibility of the source. Do other sources support this information? If you found one source, I bet you could find 2, 3, 4, lots of sources that are similar. So see if that's true. And do these other sources confirm what this author found, or do they contradict what this author found? That's interesting. The original source of the information. Is this original work, or is it a description of somebody else's work? Ooh, don't we remember that fun game when we were kids called telephone, where you sat around in a circle and somebody whispered into somebody's ear a statement, right? And by the time you got around to the end of the circle, the other end, that was not the same information, right? Yeah, well, that happens, especially with news sources, when they're interpreting the science. If this is not the original source, then you don't put much credence in it. You could, if this is a review article in a scientific journal where they've taken sources from all over, put them together, and assimilated them. Yes, I trust those. Is this the entire article, or is it a small portion of it? Or has it been edited and reworded? Ooh, not good for science. Is this original work, or did the information come from somewhere else? Yeah, we want to know that. And that's not usually helpful. You want the original source. All right, and then finally, part 3 is this an appropriate source for your project? And that's what I said before. Is it relevant? Is this helping you answer your question? Relevant source. Does it have the information that you need? So it can be a relevant source and not have that particular information that you need. Maybe this is a study for the my little topic that I gave you as an example. Maybe it's a study of New England fishing and how marine life has been affected by ocean acidification, which is a good one to use, but it's definitely still not South Carolina waters. And also, don't forget that you have to include your references in APA style. So don't forget to include the references. All right. Backwards. What in the world? I cannot get the hang of these arrows. Hello. If you need any help, this is kind of a long assignment for Project 2 proposal, right? The week 2 project proposal. Ask for help if you need help. Ask me anything, any questions you have. If something is just stumping you, you have no idea how to answer this question. Please ask me. I will email you back as soon as I can, and I will answer the question. That's what I'm here for. That's why I have this job, so that I can help you. Yes, to interpret, to give you some science information, but also to help you with the assignments, to help you understand them and get to a point where you can answer the questions that are there, right? Dr. Janie Sigmon, m.sigmon@snhu.edu. That's me. So ask and I will answer. Have a wonderful week this week.